video 4 for Excel and macroeconomics. In this video, we are going to cover line and XY diagrams. So first, I'm going to show you how to do a line chart. Secondly, we're going to insert a second y-axis, so second vertical axis, in case you want to plot data of very different scales. And lastly, I'm going to show you an XY diagram, and we're also going to perform a regression on the data there. Project 8. Create the graph below. The graph shows the percentage change of both exchange rates with respect to the first day of the observation. You're just allowed to type into the red cell. We know that from earlier problems already. And then copy the function in the yellow cells afterwards. Add the plot. Label the horizontal axis and norm the vertical axis. So in brief, we are supposed to create this chart. So project 8. Okay, what do we see here? First, we have several dates, and then we have the exchange rates of the Polish zloty versus euro and the Czech krona versus the euro at these given dates. And we're supposed to calculate the percentage change with the first observation date being the basis. So the percentage change, starting with an equal sign, is whatever date we have. So in the respective row, there's nothing to fix. It's always going to be the exchange rate in the row of this formula. So when I copy it to, say, row 8, I want to have it referred to the exchange rate in row 8 and divided by the exchange rate of the first observation. So this basis is supposed to be fixed to the row 5. So I press F4, F4 again, so that only the 5 is being fixated. And why do I not fixate the column C? Very easily, because I want to copy this equation or this formula to the right to cell F5 and have it shifted to the Czech krona versus the euro. Okay, very well. Just let's copy it for a bit to try if it works. So this, for example, shows the percentage change given the exchange rate on 7th of January versus, or with the basis, the 2nd of January. Okay, apparently that works. So I double click on that square on the bottom right of the highlighted cell. And here what I do is I jump to the end of the table. So control, arrow down, arrow to the right. So I have cell 502 highlighted. And then control shift, arrow up. And then I hold control D to copy the formula downwards. Okay, very well. So we calculated the percentage exchange rates. Now we want to insert a line chart. Again, very similar to project 7. We want to first have an empty piece of paper and then from scratch add the data that we want. So please highlight any cell that has none or that has only neighboring cells that are empty. And then click in the menu on Insert. And in the chart section, there is in the first column, second row, line chart. And as I said before, you always want to select the first one, unless you have a very good reason that you know of. But here we want to select the first one. So we get this empty sheet. You can put it somewhere, it doesn't really matter. And then select data. Data series that we want to add. So add the first one. Here we have a name which is written in cell E4. And the values we're going to connect to this name are, after deleting that empty vector from E5 all the way down, so Control Shift arrow down. So we include all percentage changes with respect to the zloty versus euro, and hit the OK button. Okay, then I go back, so serious names is, I just click on one of these, hit Control arrow up, so I don't hit Shift. By hitting Control and arrow up, I jump to the first cell that is filled with some content upwards, and series values. I delete this empty vector, highlight the first cell in the range of that I want to select, which is F5. Push Control, Shift, and then button down or arrow down. Okay. Now let's see what we have. It looks quite okay. So there are a couple of things that we want to add. So first, there's the horizontal axis. I click on the chart, somewhere on the chart, get this new menu categories, find the chart design again, select data, and then on the right hand side of this data source field, you find horizontal axis labels. Click on edit, and then I select the first date, 2nd of January, Control Shift arrow down to select the whole range of dates and see how it looks like. Okay, very nice. There's still quite a bit of a difference to the chart that we're supposed to produce. So you see we have the labels here, but they're formatted a bit differently. There's a legend. The lines look a bit thinner, and 0.5 is that we should norm the vertical axis, so it just shows the relevant area. Okay, let's start with the horizontal axis. So you double click on the labels here, and in the menu you scroll down until you see the subcategory number. You open that subcategory, you find the category date, and you can select which type of date is supposed to be shown. So we want, as an example, this. So while the menu is open, I click on the vertical axis labels, and I find axis options, bounds, and the lower bound is supposed to be 90%, I think. So we just hit 0.9. We also want these labels to be percentages. So when you scroll down in the same menu, in the subcategory number, you can say that is not just a general type of figure, but it's a percentage with 0 decimal places. Does that look like what we want to have? Yes. Now the horizontal axis labels changed. So select these again. And then you find here in the top several menu categories, and we find size and properties. And we say text direction is not horizontal, but it's rotated. Next, we want to have the data rows, or the lines, we want to have them a bit thinner. So select one of the lines. Make sure you select the whole line and not just one data point. So if I click again, it will select only that single point and not the line anymore. So you select the line. Or maybe you have to unclick it and then click it again, but you see several highlightings on that line, and then you will have selected the whole line. And you click on that fill and line properties here, and you see width, which is currently 2.25, and we drag that down to, say, I don't know, 1 point. or 1 PT, and the same for the red one as well. And then last but not least, we want to have a legend to show us what the two lines represent. And whenever you want to add something to an already existing chart that is not already in the chart, you find in this menu category on top of Excel chart design on the very left, add chart element. And you can add anything that could be added to the chart. For example, a legend. And we want the legend on top. Very nice. Okay, I think this is pretty much what we were supposed to do. So let's see what project 9 brings. Project 9 is about 2 vertical axes. So for this project, we have data from a stock, BVB stock, and the SDAX index, which collects a group of stocks and represents therefore an index for all these types of small stocks. So, but these prices are so different. So this one stock trades at around, I don't know, 10 euro, and this index trades around 2,000 euro. And if you were to represent both of these stocks into a line chart, one of the two, so probably the lower one, the red one, would just range at the very bottom of the chart. So here it does make sense to add a second vertical axis in order to show that the values are pretty much different, and then there's still variation in that line. And this is what we are going to do. So see project 9. So what we find here is first the date or the observation date of a specific price. So the price on 31st of October for the SDAX was 2,400 and a bit, and for a BVB stock it was 10 euro 5 cent. We don't have to calculate something here. Just click in a cell that has non-written or just empty neighboring cells. Menu category insert, line chart. Again, the first one, you always want the first one, unless you have a very good reason that you know of. Just make it a bit bigger, but don't have to do that. So now we select data. First entry, we add it with the name of SDAX. So cell D11. Then in the values section, you delete what is written in that input box. Click on the first value of the SDAX, Control Shift arrow down to extend the range and include all prices from the SDAX. Hit OK. Second, again add. The name is on the very top, so I just click on some of the values here in the bottom, hit Control and arrow up. So I don't hit Shift, otherwise I would extend the range. I don't want to do that. I just click, or I just hit the keys Control, keep Control pushed, and arrow up to jump to the end. And then for the values, we do the same as we did with SDAX. So first delete this empty vector here. Click on the first value, which is an E12. Control Shift arrow down. And hit the OK button here. And as we are already in this menu, we can also change the horizontal axis labels. So click on Edit. And I suggest starting from the top because I think there's a headline which we don't want to include in the axis labels, of course. So I first hit Control arrow up to jump to the very first cell with the content. I hit arrow down because I want the first date to be the first date, not this headline to be the first in my range. And then I hit again Control, Shift, and arrow down. Hit OK. And submit this whole form here. So let's see how our chart looks. So your chart should look exactly like this, or maybe the colors of the two lines are changed in case you've selected them in a different order. That shouldn't matter for the sake of this problem. So there are two things that we see. First, as predicted, this red line, which trades at 10 euros, we can barely see that there's a variation in that line. We can't even tell what values each of the points take. Second, the label down here, the horizontal axis label, look pretty weird. So let's start with this. So double click on the label and just see where the problem is. So it might be here in number. And then see the category is of course not custom, but it should be a date. So I select date, and I think that is fine. So for the reader, it would now be visible that this is a time series with some values plotted here. Okay, and then secondly, we want to select one of the lines. And you find that the menu changes to plot the series on either primary or secondary axis. And we now select secondary axis for the blue line. And you see that the scale for the blue line travels to the right on the second y-axis, or what it's called here, secondary axis. What we can do is to refer or link this axis to the blue line. We just change the color of the figures here to blue. There's text options. Well, we can say text fill, maybe. Yep, that looks right. So you change the color of the text to blue, and the reader will notice that the blue figures on the right hand side are linked to the blue line in the chart here. I can also make this left or primary axis. We change that to red. It didn't really work, so we use that red to kind of visibly link it to the red line. And again, we can insert a legend, for example, on top to see that the red line is BVB and the blue line is SDAX. That was project 9, I guess. Yep. In project 10, we're supposed to calculate correlation coefficient between the high school grade and the exam result of a given exam. Then plot the intersections of a high school grade with the respective exam grade. That is what we call XY chart, or XY diagram. We insert a regression line and build a model to predict the exam grade of a student with a high school grade of 3.1. So we have a y variable and an x variable. So in other words, what we're trying to do is, given an exam grade and a high school grade, we want to build a model where the predictive variable, or the kind of explanatory variable, x, predicts or forecasts the y variable, the grade of an exam. So that we can say, if there's a student with a high school grade of 3.1, what is the statistical forecast for the exam grade in that specific exam? What we want to do first is You want to see if there's a correlation, so kind of linear linkage between those two. And if so, it might make sense to build a linear model on that. If not, it probably doesn't make sense to build a model that linearly explains one with the other variable. And we can simply do that by typing =correl for correlation, and then handing over the two arrays or vectors, which are ranges full of, say, data points. And then semicolon and a second array or the second range of values. And we find the correlation coefficient to calculate to 0.65. And you remember from your statistics class that the correlation coefficient ranges between -1, which is perfectly negative linear relation, to +1, which is a perfect positive relationship between the two variables. 0, by the way, is none, so there's no relationship or no linear relationship between the two variables that we're comparing. And 0.65 means there's a medium to strong linear relationship between those two. And from just like looking at the data, we can see that. So if the exam grade or if the high school grade tends to be low, then the exam grade tends to be better. Whereas here, the high school grade is worse than for the first half of the students, and so is the grade exam, or the grade of the exam. Let me draw you a picture. So if you now plot on the x-axis the explanatory variable, which is the high school grade, and on the y-axis we plot the exam grade, so E for exam, G for grade. And then we say whenever we have a low score or low grade in high school, we also find that student to have a low grade in exam, with low grade being 1 or 2, for example. Then we have a dot here, then there's one who has a low high school grade but slightly worse exam grade. And then we find that the plot with high school grades and high exam grades will look something like this. And what our linear model using a regression is doing is it fits a line through all of these dots and tries to minimize, or it actually doesn't try, but it minimizes the distance or the squared distance between the actual line and the observed dots in the chart. So try to fit a line, which could be something like this. So we minimize the squared distance between the line and the dots. And this line is a function, a linear function, with an intercept here and the slope. So how steep is the line? And we can say that this y hat, so the predicted outcome, predicted exam grade, is a plus bx, where a is the intercept and b is the slope. Or some of you might know this equation as y equals m plus nx or nx plus m or something like that, but it really doesn't matter how you call these variables. It could be a, b, alpha, I don't know what. The structure is of importance. So we have an intercept and we have a slope. And this is what we can also have Excel calculated. In order to get the intercept, we type =intercept. And then instead of just passing arrays, we need to first pass the known y's and then the known x's. So the known values to be explained, and then the known values that are supposed to be explaining the first ones. So y is labeled here in the headline, so this is the y variable, semicolon, and then the axis, the explanatory variable. And the same counts for the slope. I think there's an E missing. Slope. First, the variables that are to be explained. And secondly, the values that are supposed to explain the first ones. So the intercept is our A, slope is B, and then we have an X. Just as a reminder, y equals intercept plus slope times some observed value. Starting with an equal sign, intercept plus slope times observation. An observation means that there's a student coming to you and asking you, what is a grade that I could expect statistically to get in the exam? And if this student graduated high school with 3.1, the model intercept times plus slope times his or her high school grade calculates 2.7, so this student will likely get a 2.7 in the exam. Remember that this is only a statistical model, so it could be that the student gets a 2.0, a 1.0, or is an outlier in either direction. But statistically speaking, from all data points from the past, this is what he or she can expect. We can solve this also graphically, so I promised you to get to know a new chart or diagram. So click again in an empty cell with now neighboring cells having content. Menu category insert, and then in the second column, third row, there are some dots, so call it scatter plot or XY plot. And then just click on the first plot type to insert this empty sheet. Select data, add. We don't want to add a name, so we keep this first input box empty. The second one are X values. These are from E9 to E28. And in the last input box, we delete this value that is written in it, so this empty vector, so to speak, and highlight all Y variables. Hit OK, OK, and we find this chart here. So there's a student with a high school grade of 1.4, 1.3, who got an exam grade of 1. And in a similar fashion are all other students plotted here. And you see there is a pattern where you could fit a line. And this is what we're going to do. So you just right click on one of the dots and select Add Trend Line. So this is basically what I showed you in Paint. There are some dots, which are called here scatter plot, which you can also call XY plot. And you fit a line so that the squared distance to each of the points is minimized. You could also do that with nonlinear fashions, on a logarithmic fashion, or a power function or something like that. We don't want to do that. Instead, what we want to do is we want to display the equation on the chart and the R squared value. And the equation, this is the same that we found out to be the regression model. So the point 2 is this, so the intercept. Point 8 is the slope, which we find here in cell D32. And R squared can be calculated by squaring the correlation coefficient. And it basically tells you how much of the variation in the observed data is explained by the model. So our model explains about 33% of the variation in the data. And whether this is good or not can only be judged if you have a second model on the same data and compare those two models. So you can say one model explains more variation in the data than the other one, but you cannot say that 42% is good or bad, because it only depends on what the data looks like. Okay, that was project 10. So we found this graph. Of course, we could change the style of the chart, but we don't want to do that now. You learned how to do that in project 8 and 9. So what did you see in this video? We discovered line diagrams, line charts. I showed you how to insert a second y-axis in case that you have data of very different scales that you want to plot in one chart. And then we had an xy chart or diagram or a scatter plot. And I showed you how to do a regression model, so a linear model to explain data and do forecasts in case that you get new observations. Thanks for watching. Let me know if you have any questions. Otherwise, I see you in the next video.